Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at differentiation, specifically the product rule. And take note, this is part 13. Make sure to subscribe so that you don't miss out on any of our future uploads. And I encourage you to check out all the other parts prior to this part 13. You can also go over a list of playlists that we have made, subscribe, and go over each and every playlist. It might be beneficial to you. Now let's move on with the product rule. Suppose I have the function y is equals to 2x minus 1 raised to the power 5 times 3x plus 4 raised to the power 4. And we are asked to find the dy dx, which is the first derivative of y with respect to x. One approach could be to expand the brackets considering the powers. However, this approach is cumbersome. It takes a lot of time as well, time consuming. Unfortunately, we can apply the product rule. What is the product rule, one may ask? Now suppose that we have y of x is equals to u of x times v of x. Take note, y is a product of both u and v. Then the dy dx becomes d dx of uv, which could actually be differentiated in this manner. We find the first derivative of u times the v plus the derivative of v times the u. Take note, the order there. We find the derivative of the first bit, we multiply it with the second bit, and then find the derivative of the second bit multiplied with the first bit. So that is what happens over there. Or simply, we can say y prime is equals to u prime times v plus v prime times u. And this becomes what we refer to as the product rule. Now, let's consider the first example for the day. Considering the earlier question, if y is equals to 2x minus 1 raised to the power 5 times 3x plus 4 raised to the power 4, find dy dx and the solution. So we are going to let u be the first part, which is 2x minus 1 raised to the power 5, and v be the second part, which is 3x plus 4 raised to the power 4. Then the next step would be to find the derivatives of these functions. And recall from the video part 12 in the differentiation playlist, where we looked at the quick and easy chain rule approach. This is going to help us in finding the first derivatives of u and v, implying that u prime becomes 5 times 2 times 2x minus 1 raised to the power 4, and the v prime becomes 4 times 3 times 3x plus 4 raised to the power 3. And simplifying that further, that is going to give us u prime is equal to 10 times 2x minus 1 raised to the power 4, and v prime becomes 12 times 3x plus 4 raised to the power 3. And then that would also imply that from the formula that we have on the left hand side, the y prime is equals to u prime v plus v prime times u. Substituting for those, we are going to get that bit over there, because the u prime was that, the v prime was that, v prime and v and u's we substitute in the right place. And of course, simplifying that one further, we are going to get that such that we can factor out the 3x plus 4 raised to the power 3 times 2x minus 1 raised to the power 4, and inside the square brackets or parentheses, we have that chunk over there. Then we can also simplify further so that we expand the brackets and the parentheses inside the square brackets or parentheses so that we get that, and simplifying further, grouping the like terms, then our final answer becomes y prime is equals to 3x plus 4 raised to the power 3 times 2x minus 1 raised to the power 4 times 54x plus 28. And that would be our final answer. Great then, so now let's move on to example 2. Find the gradient of y is equal to x squared times square root of x plus 4 at the point minus 3, 1. And the solution. So we let the u be x squared and the v be the second bit, which is x plus 4 raised to the power half from the laws of indices, and I encourage you to check out the laws of indices video that we have. So now we would also recall from our part 12 quick and easy chain rule approach. We know that we can find the first derivatives of u and v using this approach. So this would imply that the u prime becomes 2x and the v prime becomes half times 1 times x plus 4 raised to the power minus a half. And of course, simplifying that further, we are just going to have the v prime becoming a half times x plus 4 raised to the power minus half. And then we are going to make use of what we have as our formula from the left hand side. Then we substitute where we have u prime, we substitute with the u prime, the v prime, and the u as well. In doing so, we are going to get that bit over there. Now that is now the first derivative of y with respect to x, y prime of x. Then of course, since we are trying to find the gradient at the point minus 3, 1, where we have x, we substitute with the minus 3 so that the y prime of minus 3 becomes all of that. And simplifying further each and every term, we are going to get the y prime of minus 3 becoming minus 6 plus 9 times a half. And that simplifies to minus 3 over 2. Therefore, the gradient of y at the point minus 3, 9 is minus 3 over 2. And that is our final solution. Now, if you have made it thus far, I say congratulations to you. And I leave you with the following task. And make sure to post in your answers and your questions so that we attend to them. Thank you so much for watching Numbers Simplified. Subscribe so that you don't miss out on any of our future uploads. And remember, God loves you.